So welcome again. It's my pleasure to begin our webinar lecture with our own expert from the Hebrew University. Today we have the honor of hosting Professor Shlomo Magdassi. Professor Magdassi is a professor of chemistry at the Casali Center for Applied Chemistry, the Institute of Chemistry, and the Center of Nanoscience and Nanotechnology at the Hebrew University. He is the head of the 3D and Functioning Printing Center at the university. His research focuses on micro and nanoparticles, which are used in conductive inks and are applied to fields such as 3D and functional printing, solar energy, and biomedical systems. In addition to his scientific publication, he also has over 80 inventions which led to companies. He will lecture on 3D printing, the next industrial revolution. I would remind to all of you that following his lecture, you are welcome to ask questions by raising your digital hand. And in the next days, you will receive the recording of the webinar by mail. And now, Professor Magdassi, the floor is yours.
Thank you, Mara. I will switch to 1 second. You have to enable my share screen.
Yes. Here, you can now.
Okay. Okay, do you see the screen?
We can see, yeah.
Okay, so good morning, evening, afternoon, noon, or I don't know who's watching. I know some of my friends I do, from Argentina and from the United States. What I would like to do is to take you to a little journey that has started thousands of years ago and ended up very recently in the invention of printing as a manufacturing tool. This is considered as the next industrial revolution, and I will try to show you that this is not only pure academic research, but this is something that you can utilize and even see already in the market as a tool for fabrication. So, thousands of years ago, a prehistoric man, when he wanted to express his feelings, somehow he found a way to paint on walls. This wall painting contain natural pigments, which can be powder of mud or oxides from rocks. And it was quite a simple process, putting the pigment on a wall while mixing it with water or something. A few hundred years ago, painters like Michelangelo and Leonardo da Vinci made it in a much more defined process, and they were able to create features which are very, very small. Not as small as I will show you in a few minutes, but very small. So we're talking about paints and inks. And since we are here in a very close audience, I can tell you some secrets. The way to make a paint or an ink is very simple. You can actually make it in the kitchen. You can take a tomato or an ash or some mud, mix it in a mixer like a food processor, and you end up with particles of the pigment which are dispersed in water or in oil. If you know how to make this dispersion, you can use it for painting. So the conventional painting is simply putting white particles on a wall. What we are interested is to deliver functionality beyond color. And I will start with simple processes of painting, then go to ink printing, then go to 3D printing, and then, if we have time, we'll talk about 4D printing. So what you see here in this can is actually a black paint that we have developed. And the uniqueness of this paint is that it can absorb all the sunlight. It is black, and it can convert the sunlight into heat. Now, if you take this heat, for example, you have here a solar tower. You have many mirrors that reflects the lights into here. This will become very hot, will generate steam, and then you can get electricity. So this is exactly what we did with a company called Bright Source Energy. We have licensed our technology for making this black paint, and now this is the largest photothermal solar production in the world. There are already about 100,000 houses in California that benefit from our invention. You can see this from the sky. Once the flights in the US will resume sufficiently, you can actually see it in the desert. So this is an example of making a simple paint by spray coating or so that can be used for having a specific function. And this specific function is harvesting energy from the sun. But this is usually done by simple coating on a big substrate. What if we want to make a pattern? What if we want to write something to have a specific image? For that, we need to go to printing. And humanity took a leap, huge leap, with the invention of printing. Gutenberg is the first one who invented the printing machine. This is a replica of his printing machine. And most famous is the Gutenberg Bible that he printed at 1445. This was the first time that you could print one copy for all. So this has a real huge societal impact, which we see until today. He printed the Bible, and since then, nothing really happened too much with the printing. We have better resolution, we have a lower cost, we have a better definitions of colors, but basically this is based on taking a paint or an ink and place it on top of something. This something can be plastics, can be paper, it can be a shirt, and I assume that most of you have at home a printer. Usually the printers that we have are inkjet printers. They are quite cheap, but the ink costs a lot, which is good because this is our research field. A typical printer uses inkjet process in which you have an ink here that is jetted from a small orifice by a digital signal, and this is why it becomes a digital printing technology. This is a printer that costs maybe about $50, but you pay about $100 for the ink. We can print on paper, but we can print on anything. Here, for example, what you see is a printing technology that we have developed for printing on glass. And the idea is that you print on the glass, put the printed pattern with the glass in an oven, and then the image becomes part of the glass. What you see here on the left side is the printer. It is the size of a big room. This is a photo image of the first printer that was developed. This entrepreneur built the printer. We have developed the inks, and nowadays these inks are sold everywhere. The printers are sold everywhere in the world. And what you see here is the facade of a hospital in Harlem, New York. This is printed by our technology. So we talk about 2D printing. If you want to make something that will bring more than a color, here we have a lot of activity that I don't have time to talk about that is related to printing displays for smartphones, for computers, printing solar cells, or even printing solar cells that you can stick on the window and it will be transparent. At the same time, will generate electricity from the window. Or temperature sensors, or flexible smartphone, or a smart window in which you press a button, it becomes opaque. All is done by printing. This is called 2D functional printing. What about going into real object? Not only 2D substrate, flat substrate, to go to make a real object. On the right side, you see a wooden ball that is produced by the conventional process. The conventional process is taking a tree, cut the wood out of the tree, take pieces of this wood, glue it, shape it, clean it, glue it again, shape it again, and so and so and so. And this process takes about 1 month to achieve this. I have a friend who's an artist in Israel, and he's doing that type of structures, vases, and so takes a very long time. So imagine that you could print that object. This is going to create a real revolution. And indeed, printing, 3D printing, is an emerging technology which is based on a very simple principle. You simply repeat 2D printing again and again and again, layer by layer. This is why it is also called Additive Manufacturing process, or AM. The basic idea is that you design an object by the computer, you slice it by the software, and then you print every slice. 2D printing, 2D printing, 2D printing, until you reach the real height. This is exactly what we have done with the company. Then it was a startup company and now selling all over the world, in which that company aimed at making 3D printed circuit boards. This element exists in every electronic device. We have developed silver inks, nano inks. Nano is very, very small particles. They have developed the printer and the technology for making this type of printed circuit board. And this is selling all over the world. It is a company called Nanodimension in Rehovot. What if we want to really make a real object that we can hold in our hands like that? The idea is that you design the object by the computer, you slice layers, and you send it for a printer to print a layer by layer. So we go from a computer design to an object. What you see here is a real printed object without assembly. This is by the company Object Stratasys, one of the largest in the 3D printing world. How this 3D printing can happen? For example, this is a simple printer which prints ceramics. The basic idea is that you put a layer of a powder, and then you print on the powder, you print a glue. When you print the glue, then you put again a layer of powder, and you print again a glue. After you finish, you take out what was glued together, and you end up with a 3D object. So there is there's a variety of printing technologies. I will not go, of course, into details of the printing technology, just to give you a feel about possibilities and about possible structures which can be amazing structures. So manufacturing is going digital. A few words about the history of 3D printing. Actually, in 1964, Arthur C. Clarke predicted what he called replicator machine. So he envisioned a machine that will produce itself. Actually, this is happening already in my lab. When something is broken in one of my printers, the students are using another printer to print the broken part. A few years later, this became reality at 1996 by Chuck Hull from the US, and the rest is history. There is a variety of printing processes like powder, melting of plastics, and so So I will just show you a few examples on these technologies and possible applications of this. The first one is quite simple. Imagine that you take a toothpaste and you squeeze the toothpaste, but you move it around on the XY axis and then you go up or down. You can use this selective extrusion to make a 3D object. You can print with ketchup. This is related to a lot of activities that happens now in the world in food printing. Or you can take a filament of plastic and you heat it up, melt it, and extrude it to the same extruder. So you come from a solid plastic, make it liquid, print it, and then you end up with a 3D object. This is called FDM process, and there is really a variety of printers in the market. This started the first revolution because at this case, the printers became so cheap that it is affordable, and many people have this type of printers now at home to print toys for the children, for example. There was a lot of PR in this type of printing machines when one person printed a gun and he could stick out of plastics. This type of printer is now used for printing part of missiles, as I will show you also parts of airplanes. Here it's written in Hebrew, please print me a drone. So the Israeli army is already printing a part of flying objects and even metal parts for helicopters that are quite old and they cannot replace them because there is no budget and they cannot find replacement part. So they simply print the replacement parts. This is reality. It's already happening. Another process for printing can utilize light to make a liquid into a plastics. I will not go into the details. The idea is that you shine a 2D image, one on top of the other, and you eventually get a 3D object. This is a film taken from one of the experiments that one of my students has performed, in which you shine light and you convert a liquid into a polymer, and this liquid becomes solid polymer, and you repeat the process again and again and again, and you end up with a small or big part made of plastics. This is a very common process. It is affordable, and it's already found its way to the market in some examples that I will give you. So what we have developed, for example, processes and materials to print object that is almost impossible to manufacture by a conventional process or without assembly. So this is a stretchable polymer. What you see here, this is a gripper that we printed. We couldn't print that unless we paid maybe about $200,000 for the production. And this is utilized in the field of soft robotics. Now we are taking part in a European project, Horizon 2020, in which we try to model the trunk of the elephant to print, 3D print grippers that mimic the action of the elephant. So we can print complex structures, we can print multi-material structures without any assembly. This is simply printed at one press of a button. This is why it became so appealing to a lot of applications, as I will show you in a few minutes. This is now considered as the next industrial revolution. There is a lot of money put by governments and industry in America, in Europe, in China, everywhere. This is from The Economist that talked about the third industrial revolution. I prefer to call it the next industrial revolution because we can start having manufacturing process directly from a printer with a lot of advantages and benefits. This manufactured or fabricated object can be made of steel, plastics, biomaterials, even a car made of plastics and metal, or printing motors. So this is what is really considered as the future of manufacturing. The main advantages of 3D printing are one, that this is a bottom-up manufacturing process, meaning that you don't waste any material. You just place the material where you need it, the amount you need it, and only when you need it. You can produce very complex structures. You can print objects that are made of a variety of materials. You don't need to assemble parts. You can do it at home up to a certain extent. And you don't need any tool. You just have to design in a computer, press a button, and here you are. Now, the obstacle to go to real manufacturing is the cost. For example, if you want to make a simple object made of plastic like that, by conventional printing, you use extrusion, and for making the extrusion, you need to prepare a mold. This mold can cost something like $100,000, $200,000, depending on the mold. Meaning that if you want to produce only one unit, the cost of that unit will be the cost of the tool that you have designed, that you made. In this case, could be $100,000. But if you make many parts, the cost will reduce with the number of parts. This is the blue line. Whereas in 3D printing, the cost of the first object and the 1 millionth object will be the same. So there is a point in which it is worth printing, up to which above that you shouldn't do printing because of cost. So as long as we are in this range, and this range can be hundreds of thousands units or millions of thousands of units, it is economical to use 3D printing for manufacturing. And this is actually done. For example, Nike print already shoes. Imagine that you go to a store and you scan your foot, you scan your feet, and then you print the right shoe just for you. So this is coming into personalization object, but this is already produced by Nike. In the past, this process was related to making a fast prototype to see how it feels, how it looks, and then go to conventional manufacturing. Now you can actually print shoes. If you can print shoes, you can print anything. Actually, 3D printing or any printing process is really very simple to scale up. And what you see here is printing large object. This is object that is printed about 2 meters tall by an Israeli company called Massivit in a few hours. This is a bridge in China. So all you need to do is to tailor the printing technology to the printing material, and you can even print houses. China is leading in this field, and the idea is that the ink is actually concrete. So you make a liquid concrete. The trick here is how to make this concrete solidify quickly enough not to collapse. So you can print houses, and in China, there is several villages already printed by this type of printer. And you can see here some examples of printed walls, printed buildings, etc. I expect this to go into a much larger scale in the very near future. We also participated in a competition of building on Mars. And the idea was that we take soil that resemble Mars and make an ink out of it and print the future houses for astronauts. This is quite futuristic. But what's really happening now, by NASA, for example, they invented a printer that can print a pizza in space. You could ask why. why print a pizza in space? I think this is a demo or proof of concept that you can make food by simple manipulation of the printing, sequential printing of the object. So there are already companies in the world who are selling printers that you can print chocolate, sophisticated food. I'm involved with a company called MeatTech that is aiming at printing meat or meat replacement by using tissue cultures. There's a company at the Hebrew University by Professor Braslavsky and Shoseyev who is making food replacement or meat replacement by mixing proteins and polysaccharides. In this company, they are using tissue cultures to grow actually the whole steak with the muscles and with the fat areas and so and so. 3D printing can also go to fashion and art. We have a long collaboration with the Bezalel Academy of Arts and Design. And here is some examples of printed design, fashion wear, and so. You can print all kinds of materials, plastics, metal, glass. For example, MIT researchers has used printers that melted glass and then start to print that glass to form 3D objects out of glass. This is, of course, done at very, very high temperatures. So we have developed a process that you can print glass even at room temperature. So what you see here is a small vessel for the chemical lab that can withstand high temperature, printed at room temperature. How small can we go? We can go very, very small. You can see on the right side, you can see an image of a hair fiber. I don't have too many, but this is a hair fiber. And this is printed objects at the size of less than 1 hair fiber. So the feature size is much, much smaller. It comes into the Colosseum printed, for example. All this Colosseum is the dimension of 1 diameter of a hair fiber. We can print from metal. For example, you can take a powder metal and use a laser beam to melt locally the powder, and you end up with metallic particle. If you can make a metallic particle, you can use it for blades, for rotors, for motors, but also you can use it for medicine. For example, this is actual photos of a printed part of a skull of this young patient, and it's working. This is a jaw, printed jaw, working. It's in real life. You can have hearing aids, personal hearing aids, prostates for elephants or for children. And you can print, this is actually already happening. You can print your teeth or bracelets, simply going to the dentist, scan your inner part of the mouth, press a button, and in a few hours or few minutes, you have your teeth replacement. In Israel, there's a company called Synergy that are printing for making, for example, object models for the surgeons so they can practice on the model before they go to operation. Or they can design a tool for the surgeon that will enable him to cut more efficiently what is required. So this is not future. This is happening now. This company has offices in hospitals and they are printing together with the doctors. So if we are in the medical field, what about printing organs? This is really very, very tough, but I believe that it will happen sooner than most of us accept. Of course, when we print organ, it's not enough to print the shape of the organ. You need to have it functional. So can we print a heart? Or can we heal a broken heart? For this, you need to print in water. So we have developed a variety of technologies to print in water. And what I would like to show you here is a work done by Professor Tal Dvir from Tel Aviv University. He is a biologist. And here you can see a printed hand made of a gel. This is not functional, but he also tries to print organs. So he has printed multi-materials. And if you can print multi-material, you can print blood vessels. So if you can print blood vessels that can supply nutrition to the cells, you can go to the next step, which is printing a heart. So this is exactly what he has done, a small heart for a mouse, but this heart already contains heart cells. You can see here the beep, the beeping of this heart cell, the heartbeat. So we are on the way to print organs. There is a lot of activities all over the world towards printing organs. So I talked about 2D printing, 3D printing. What's next? 4D printing. This is the new frontier of 3D printing. Here we printed something that has a memory and can change its shape with time or with temperature. We use a material called shape memory polymer. And imagine this tent that we print, squeeze, put in the body, and in the heat of the body, it will reopen. So this is leading us to the new world of 4D printing, meaning 3D object that can change shape by humidity, by water, by temperature, magnetic field, by light, by whatever. So again, we have collaboration with students of art in Bezalel. And here you can see work by Shira Eliezer that made moving jewelry. You go out to the sun and the ring opens up and exposes a diamond. Or another student designed a shoe that if you travel in the world, you go for work with this flat heel shoe. You finish the day, go to the hotel, heat it up, and you have high heels so you can go to a party. We can also use this thing to activate opening and closing of something. You can see here that we put a box in a warm water and the box opens up. Or we can shine light on this box and it will open up. So you can think of putting something in that box or think of it as a valve that you can utilize for something. This something can be, for example, drug delivery system. So maybe we can print pills that will release the drug at will. Or maybe we can print a pill that will look like that, or maybe like that, that can be programmed and start to release the drug only when it reaches the intestine. For example, this drug pill is closed in our stomach, opens up at our intestine. So this brings into the next generation medicine. There is an initial activity in the world in this field. We are also starting to be active in this work. You can cause changes of shape and movement by external fields. For example, here we use magnetic field, or we can make soft robots that will move because of external magnetic field. So this is again going back to soft robotics, magnetic walkers, and moving objects. I just want to say something about our activity. I have my own lab at the Hebrew University with many printers, of course, all the equipment that is required for making this printing happen. But we also established a center for functional and 3D printing. This is a photo of the center that is open for all students, all faculties, startup companies, big companies, defense companies, and this is really an active field of research. So in principle, we are now at the stage in which we are moving from rapid prototyping into a real manufacturing. You can see here Adidas doing Adidas printing shoes, and many companies are starting to utilize printers to fabricate required object. So I cannot end without bragging with the new company that we just established, actually only 2-3 weeks ago. This company aims at printing wood. It is led by my former PhD student who just finished at the university, and also Professor Oded Shosef from agriculture. And the company, Dykey Wood, is making 3D objects made of wood and only wood, while taking a raw material which is waste wood, and you take a glue that is made also from wood called nanocellulose, and you end up with finished products which are the wooden object. What's next? I hope I didn't confuse you with too many details. It's really an exciting field. And I don't know what is next. I have in my lab quite a lot of ongoing projects that I hope to be able to share with you, really exciting ones in the future. And what I say is that we should fly with our imagination and print our dreams. Here, this is a 3D printed shape memory bird. It remembers that it can fly. I would like to end up with thanking the people which made sections of this work, the funding agencies, and I would like to thank you for your attention. It is quite weird that I cannot see any of you. I hope that you see me, and I'm open for questions.
Thank you very much, Professor Magdassi. It was really very interesting. So we are now opening our question and answer session. And you can raise your hand or write your question. So we have a first question from Amir Khen. What is the fidelity level of a 3D printed metallic object compared with traditional production techniques? Is it possible to print metallic objects that fit for use under ultra-high vacuum?
The main challenge in metallic printing is the mechanical strength. It's a very good question because only last week there was in the Israeli TV news an item about printing parts for helicopters, metal parts for helicopters, because they ran out of replacement parts. The helicopters are too old, and it passed all the tests, meaning that mechanically you can get a good mechanical properties. We do have also in our lab metal printer. Regarding vacuum, I assume it should be fine. I don't see a reason why it shouldn't be. I haven't tried it, but I think it should be okay. The fidelity depends on the printing mechanism, the printing material. I cannot say that it is excellent for any material, but there is a great variety of possibilities that you can utilize.
Thank you. So I would like now to open the microphone to Matan Dahan. Matan, I allowed you to talk. If you want to ask here, you can ask.
Can you hear me?
Yeah.
All right, perfect. My background is from the environmental field, so my questions are regarding that. First, I was wondering about resource efficiency compared to more conventional manufacturing. Are there any numbers if you use 3D printing versus molding, how much resources are saved? The other one is regarding waste material, like you showed from wood, and what are the developments in the pipeline for using end-of-life cycle material, waste material, to create more novel products. And the last one is regarding what you discussed for really briefly about 3D printing of meat, which I think is highly, highly important, and how far are we from that, and what are the chances of reaching it in the near future? Sorry for so much. Thank you.
Okay, I hope I remember all the questions. The first one, the beauty in 3D printing or in printing in general is that essentially you use only the material that you need, meaning that you don't put a lot of material and then get rid of some of it. So this is a much better economical way. Of course, I cannot say this is in general. It depends on the process, on the type of materials, but this is already happening. Second point regarding using recycled materials. I showed you about the wood that we do, but there are already companies that are using plastics from recycled bottles. So there is a machine that you can put actually pieces of plastic bottles and print. The last question regarding meat. 3D printing meat, there are two directions. One is actually to make a kind of a meatball, like a hamburger, that will be made of vegetables or vegetarian sources. I call it the meat replacement hamburger. And then you use the printing to make a mixing. For example, you can print material that will give you a feeling of a muscle, and you can print the material that will give you a feeling of an oil or a fat. The other direction is taking cells and grow from these cells the tissue, including the muscles, including everything. So this is something that is related to a lot of biology, tissue cultures. There are several companies in the world which are working in this direction. This is a long journey. Since people have shown that you can print a steak, I think that the last report was the cost of about $10,000 per one steak. So the race is how to make low-cost processes. Did I answer your questions?
Yes, indeed. Thank you.
Thank you. So now we'll open the microphone of Joseph Oscar. Yossi, you're allowed to talk now.
Thank you. Professor Magdassi, I understand that by 3D printing, you can shorten the process of, shall I say, die molding, eliminating and cutting time when you create a die casting or whatever. The issue is to find, in this case, let's call it ink, that is sufficiently fluid. Can it be made of any material? That is the key question.
Okay. Okay, so my field is material science and chemistry. So we do develop materials for printing. I cannot say in one sentence yes, but I think we can almost say yes. Depending on the material itself, it's not only that you need to have it liquid. There's a lot of needs from the ink, but these challenges can be addressed and are already addressed. Of course, at this point, you cannot reach high-performance polymers. So we are working on a project with the company on making a material that you can print and get high-performance polymers, or printing Teflon, or printing ceramics. So each type of need requires tailoring and development. And this is why we are working in real heavy research in this field. So in principle, yes, it's a way. In some cases, it's quite already achieved. In some ways, it's on the way. Some ways, it will be it will take longer.
Okay, thank you. And now we have Eli Zilka. You're allowed to talk. Eli, you should open also your microphone. Okay, so maybe we will go to the chat. So Patricia Kleeman, she's asking, what is the feasibility, cost effectiveness for 3D printing to replace or eliminate traditional offset processes for printing books?
I think that printing books is, at this stage, does not require really 3D printing. It requires 2D printing. And there was a company in Israel maybe 10 years ago that tried to develop a printer that can print a book on demand. I think that the technology worked, but the business case was not strong enough and they did not continue with it.
Okay, so now we'll try to go back to Eli again. Eli, can you speak now?
Can you hear?
Yeah.
Yes. Okay. Can these materials be reused for different objects? And a second question: are these materials, if they are thrown away, to join this big island of plastic in the ocean? Is it going to be bad for ecology?
I think that once you make the plastic part, it will have its own life, which is exactly as any other plastic part. I consider 3D printing or printing as a hammer. It's only a tool that makes everything more efficient, more economical, faster, with many advantages. But if you print a 3D part made of plastic, for example, you can throw it to the ocean or you can recycle it. So it's up to us. It's not something that is unique to 3D printing, I think.
Okay, thank you.
Thank you. So now Raman, he's asking, you showed construction of housing in China. What is the stability of such buildings in earthquake zones such as China?
Yeah, I don't know enough about of this issue. It is definitely a big issue, but if you saw in the video, they built actually 2 walls, and in between they had to put the additional construction materials. I don't think it is there yet, but it's only a question of time, I'm quite sure. Like to make high performance concrete and so already exists in the world, so it's a question of time how to convert it into something that you can rely on in earthquake and so. I don't think that 3D printing is a magic bullet that can do everything. I assume that in the future it will be part of a production chain. For example, with the houses, it will help you produce sections of the house. Which sections? Depends.
Okay, now we have Moti Anavi. I allowed you to talk. Moti, you can ask your questions.
Thank you. Hi, Professor Magdassi. Thank you very much for a very interesting presentation. My question relates to objects that are made from multiple materials. So just as an example, a frying pan might have aluminum, and it might have Teflon, and it might have copper and plastic. How flexible or unflexible are 3D printing methods in constructing multi-material objects?
If you ask me in a general way, this is the most major and urgent challenge in this field. Multi-material printers. There is only a handful of printers that can print several materials. By the way, one is by an Israeli-American company, Stratasys, that they can print a drop of a liquid or 2 drops of liquid, 2 different liquids in one spot. I think this is still not common. I expect this to be a major part of the activities in 3D printing. I'm aware of several companies that are working in this direction. So this is called multi-material printing. And actually now I'm exploring possibility of buying a new multi-material printer for our lab. Some call it also digital materials, for example, PolyJet technology by Stratasys. So you can take and put a flexible material close to a rigid material and get something interesting. But there are not sufficient number of printers that can print metal and glass and Teflon and so at the same time. It will happen.
Okay, thank you very much.
Welcome.
Thank you. We have a question from Michael Schneider from the chat. What is preventing broad adoption in manufacturing, and at what industries should see the largest cost reduction from 3D printing?
I cannot give a clear answer because it depends on the product that you want to produce. I showed only a very naive plot that shows the cost reduction by number of units for conventional manufacturing and also by 3D printing. This question is heavily dependent on the real application, the real product that you want, and there is no general answer. I can tell you that the world now is moving from prototyping into manufacturing. HP, for example, has developed a printer that claimed to be very economical until you reach something like a few hundred of thousands of pieces of objects, and it is still economical. So I think that we are in transition state between prototyping and manufacturing. Again, depends on the industry. I cannot think of one industry that is not relevant. Ceramics, tiles, biomedical, everything. So this is quite general.
Okay, we have now a very business-focused question. I'm interested in cement 3D printing. There are several companies using a robotic arm against gantry system. I want to build low-cost housing in the USA. Do you have companies in Israel that are making these products? Are you using such machines in Israel?
Not that I'm aware of companies doing that. In Israel, no, to the best of my knowledge.
And David Stembler is asking, in your opinion, what is the current technological roadblock that is preventing the next major 3D breakthrough?
I'm very happy to say that the most difficult part is the materials. But it's not really absolutely true because it's a combination of materials and technology. For example, we mentioned multi-material printers. So this is a technology. But the main challenge is still materials.
Okay, and Sarah Dobner, she asked, how significant is the design programming component in the 3D printing process? If this is significant, then we cannot say the unit cost is unchanged vis-a-vis volume of production, can we?
Yeah, the design, I assume that you talk about the software design, is quite simple. It's not something that is any barrier at all. My students operate it quite easily. My son is an industrial designer and he uses it frequently. So the design is not a big issue. On the contrary, engineers use design, for example, to make parts with very good mechanical properties, and by the right design, they can reduce the weight tremendously. So this is for aviation and so. So I don't think that design is an obstacle.
And few people already asked, which program have you been using for printing?
Depends on the printer. Usually, conventional STL file or SolidWorks and so you can get it. But it's really depending on the printer. You have a lot of open source programs. You can download it from the internet, and I must admit that this is not something that I know. I usually ask my students and they do it.
And Jonathan Levis, he is asking, if food can be created, can we think of delivering it to feed people in areas of the world which suffer from hunger?
I think this is not really related to 3D printing. Think of it as a machine that can make a product. For example, if there is hunger place and so, you can control the composition of the food that will have the right supplement, the vitamins, the essential amino acids, and so you can actually make it in a much more sophisticated way, so you do not waste the unnecessary components of the food. So the short answer is yes. The long answer is it depends.
And I think we have time for maybe two more questions. So Eitan Avni, he's asking, what is the highest possible 3D printing resolution? Can it be applied to produce simple semiconductors?
Yes, my friend Eitan Avni, we studied together chemistry. Hi. Now he's in the US. The resolution of the printers can be even below 1 micron. So this is definitely in the range of semiconductors, is hundreds of nanometers. I don't think the technology is mature enough, but we already print sub-micron features. It will take time until it will replace conventional semiconductor industry. I'm not sure that it will because it's mass market and so, but it might be.
And okay, so the last question is from Guy Price. Can you please elaborate on solar printing on windows for high rise? Is there any solution that is currently viable for use? Can you please give an overview as to where this industry is and how close we are for commercial sun harvesting from solar energy?
I assume that you mean using only solar cells that are mounted on windows. So this is the field of transparent solar cells or semi-transparent solar cells. This is an emerging technology. I'm working on this field together with Professor Leoz Edgar, who is an expert in solar cells, and we have filed the patent and so, but to the best of my knowledge, this is not mature at this, not mature yet. It will definitely happen because the windows provide a very large surface area, so this is a natural place to put the solar cell. The main challenge is that if you make it, how to make it transparent. There are quite many big groups in the world working on this direction. It is very challenging.
Thank you very much. So I think this was our last question, but I'm sure I see there are many other more questions that maybe you can write me by mail and I will forward to Professor Magdassi in the next days. Thank you everybody for joining us. Thank you a lot, Professor Magdassi, for this lecture, which was very fascinating. And hope to see you in the next webinar next week.
Thank you very much, all of you, and be well. Bye-bye.
Thank you.
Bye.